Okay, linear relations and functions. We're going to go through this quick, and then you guys are going to do some practice here. So we talked about the linear part. What's the key word in the linear? It's the line, right? And we know that line is going to be a line that has constant slope. So if I have a slope that's the same, I'm going to get a line. So if my x and my y, what can you guys tell me about the slope of that line? Is it positive or is it negative? It's positive. All right? And we define slope just as Tosca told us earlier. Rise over run. And you might also see it down the road as delta y over delta x, where delta means the change in. Okay? So this is a positive slope. Show me with your hands, what would it look like if I had a negative slope? It goes downhill. So as you're going left to right, if you're going uphill, it's positive. If you're going downhill, it's negative. Yeah.
So did they say it was delta x over delta t? Because in physics we did that.
Delta x over delta t is a little bit different. I mean, well, okay, the concept is the same. Delta is change in.
Yeah.
So if you have change in x over change in time, it depends on what your concept is, but it could be a momentum difference. But that's, yeah, same thing. Delta means change in. All right? When you guys get to calculus, you focus on this piece, and what you do is you let this delta, this change in, go very, very, very small. You go infinitely small. That's all calculus is. It's letting things go to infinity. All right. So that's my positive slope. That's my negative slope. My horizontal line. What is that a slope of? Somebody tell me nice and loud. A horizontal line, it's a slope of
0.
0, or is it undefined?
0.
Why is it 0?
It's constant. It's changing.
What's not changing?
Well, the line, the slope is the same. The y.
The y is not changing. What's my rise, right? My rise is 0. What's my run? Whatever you want, right? So that's going to be 0. What about vertical? Undefined. Why is it undefined? What's my rise? If I go between 2 points, right? If I take a point right here on the x-axis and I go up, that could be my rise. Could I go up further? Yeah. So my rise could be anything I want. What's my run? How far over do I go?
0.
0. So I get something over 0, which is undefined. Okay? I can't divide by 0 and get a definite answer and get anything that I want. All right. We have two things, parallel and perpendicular. All right? If I have a slope like that, line N and line M, this one is pretty simple. If they have the same slope, they're going to be parallel. Yeah? All right. What happens if they are perpendicular? What do I need? Yeah, Josh. What's that?
Negative reciprocal.
Negative reciprocal, what does that mean?
So the slope will be flipped or whatever and negative.
Okay, good. You guys agree? All right. So if the slopes are opposite reciprocals, we're going to get perpendicular. The question becomes, why? Besides your algebra teacher told you. Any ideas? So let's say we had a slope of a half, right? What would, oops, that's wrong. What's my error there? Yeah. Oops. Okay. So the y of that is important. So let's imagine that we had this and we just looked at these two angles, right? What's this piece here, this horizontal piece? How far is that? If I have a slope of 1/2, sorry. 2. And what's this piece? 1. Okay? And I know that these two, this is theta, this is phi, they add to 90. Why do they have to add to 90? because it's a triangle where the angles on a triangle add up to 180. So those are 90. All right? If I want this to be 90, do you guys agree that these two angles are going to make a 90-degree angle there? Yeah, so that'll make it perpendicular. All right? Well, if I draw my triangle, there's my 1 and my 2, and I draw this angle, and I make my triangle, what's this piece now going to be? It's going to take this, and it's going to go like that. So I have phi and the 90, phi and the 90, it's going to flip down. This 2 here is related over there. So it's going to flip. And why is it negative? Because as I'm going left to right, I have a negative value. So that's why it's opposite reciprocals. Okay, we're looking at these triangles and what happens as we flip them around. Okay. Go. Okay. We have our linear equations. We have something called standard form. And standard form sounds really important. It is important, but we barely ever use it. So we have ax plus by equals c. Is that the form that is most helpful to you? No. What did you guys use on the warm-up? Right, and what's that called? Slope-intercept. So we have our standard form. It doesn't help us a lot. A and B, C are integers. Can you get from standard form to slope-intercept form? You can. You have to solve for it, but we can get there. All right. And we have the greatest common factor between them is going to be 1. All right, and this is what we talked about earlier. So can someone remind me what a function is? Yeah.
With only one output, and relation can have multiple outputs.
Good. You put one thing, you get more than one thing out. All right. Both are sets of ordered pairs. The question is, if we go back to our goal problem, one thing in, one thing out, how is this going to look graphically? So we can understand it if I give you sets. You can understand it if I give you a rule and ask questions. But the question is going to become, what does it look like graphically? All right. So we went through this, right? Who's your father versus who's your uncle? Who's your father? Is it a function? Yes. Who's your uncle is a relation. I'm going quickly because I can tell you guys are fading. All right. Is that going to be a function? Take a guess. So what does it mean to be a function? It means if I put one thing in, I get one thing out. Well, which axis do I put in? Do I put in the x-axis or do I put in the y-axis to start in my ordered pair? X. So let's pick a value. Let's go over this far. All right? My output is right there. Is there anything else that I get an output at this x value? No. What about over here? There's my output. Any difference? No. Back here, there's my output. I don't hit the graph number. So what do you think? Is this going to be a function or a relation? Function. Good. There's no point where I can draw that line and hit it more than once. Versus, what is that? Is that going to be a function or a relation? Relation. If I put in where I have this vertical line drawn this x value, well, I get an output here, here, and here. So this value goes to 3 things, which makes it a relation. So we have our vertical line test. If you can draw a vertical line and it hits it more than once, it's going to be a relation. If it hits it only once, it's going to be a function. So let's go back to the original question. Is every line, so every line that we graph, is that going to be a function or a relation? Okay, lots of mumbles of functions. Is there ever going to be a vertical line that's going to hit it more than once? No. Right? Unless it is a vertical line. Okay. This makes it not a function. All right. That's the first 3 sections of chapter 2 in about 15 minutes. Okay. So that's why I'm trying to get the big ideas out there, because I think that what you're really going to learn is